Imagine a future where Mars, our barren and dusty neighbor, is transformed into a vibrant, habitable world. Rivers flow, forests thrive, and humanity has built its next great home among the stars. Terraforming Mars is no longer just a dream of science fiction. It's a vision that captivates scientists, futurists, and dreamers alike. But how do we turn the red planet into a green oasis? Let's explore the incredible steps, immense challenges, and profound rewards of transforming Mars into humanity's second home. Step 1. Warming the planet. Mars is a frozen desert with an average temperature of 60 degrees C, 80 degrees C. To support life, the first step in terraforming is warming the planet enough for liquid water to exist on its surface. How could we achieve this? Greenhouse gases. We could pump powerful greenhouse gases like carbon dioxide and methane into Mars' thin atmosphere. These gases would trap heat, creating a greenhouse effect and gradually raising the planet's temperature. Orbital mirrors. Another idea is to deploy massive mirrors in orbit around Mars. These mirrors would reflect sunlight onto the surface, focusing heat on targeted areas and melting polar ice caps to release carbon dioxide into the atmosphere. Asteroid impacts. A more radical approach involves directing asteroids to impact Mars. The collisions would release heat, and water-rich asteroids could deliver essential resources. It's a high-risk, high-reward strategy that would require precision and advanced technology. Albedo reduction. By darkening the Martian surface, we could reduce its reflectivity, or albedo, allowing it to absorb more heat. This could involve spreading dust or even introducing microorganisms designed to darken the planet's surface. Each of these methods presents technical challenges, but together they could set the stage for the next crucial step. Step 2. Building an atmosphere. Mars' atmosphere is incredibly thin, less than 1% the pressure of Earth's. To make the planet habitable, we'd need to thicken the atmosphere to retain heat and shield against radiation. Sublimating polar ice. As the planet warms, frozen carbon dioxide at the poles would sublimate, thickening the atmosphere. This process would accelerate as temperatures rise, creating a feedback loop. Nitrogen and oxygen. For a breathable atmosphere, we'd need more than just carbon dioxide. Nitrogen could be extracted from Martian soil or imported from other celestial bodies. Machines like NASA's MOXIE experiment, which converts carbon dioxide into oxygen, could play a pivotal role. A thicker atmosphere would not only trap heat, but also provide better protection against harmful cosmic and solar radiation, making life on Mars safer. Step 3. Introducing water. Water is the foundation of life, and Mars has it, just not in liquid form. The polar ice caps and underground ice reserves hold significant amounts of frozen water. By warming the planet, we could melt this ice to create rivers, lakes, and even small seas. Another approach involves importing water-rich comets to deliver additional water. A functioning hydrological cycle, complete with evaporation, condensation, and precipitation, could emerge, providing rainfall and a self-sustaining water system. This would be essential for agriculture, drinking water, and the development of ecosystems. Step 4. Planting the seeds of life. With warmth, an atmosphere, and liquid water in place, we could introduce life, starting with hardy microorganisms, microbial pioneers. Genetically engineered microbes, such as cyanobacteria, would be introduced first. These organisms can survive harsh conditions and perform photosynthesis, converting carbon dioxide into oxygen. Hardy plants. Once oxygen levels increase, more complex plants like mosses, lichens, and grasses could be introduced. These would stabilize the soil and begin forming the foundation of ecosystems, forests and ecosystems. Over time, conditions would improve enough to plant trees and create forests. These ecosystems would regulate the water cycle, enrich the soil, and provide habitats for future animal life. This gradual greening of Mars would transform its landscape, creating a planet that feels increasingly Earth-like. Step 5. Introducing animal life. As oxygen levels rise and ecosystems stabilize, we could begin introducing animals to Mars. Insects and soil creatures. The first arrivals might include insects like bees for pollination and worms to aerate the soil. Small mammals and birds. As ecosystems become more complex, species like rodents and birds could be introduced, playing vital roles in maintaining balance. Over time, Mars could support a rich and diverse biosphere, a thriving world teeming with life. Challenges of terraforming Mars. Turning Mars into a habitable planet is an inspiring vision, but it comes with enormous challenges. Radiation. Mars lacks a strong magnetic field, leaving it vulnerable to harmful cosmic and solar radiation. Building artificial magnetic shields or underground shelters would be essential for early settlers. Timescale. Terraforming Mars would take centuries, perhaps even millennia. It's a generational project that requires long-term commitment and collaboration. Ethical dilemmas. What if microbial life already exists on Mars? Transforming the planet could destroy native ecosystems. This raises profound ethical questions about our right to alter another world. Technological hurdles. The technology needed to warm the planet, build an atmosphere, and sustain ecosystems is far beyond what we currently possess. Advances in robotics, artificial intelligence, and materials science would be crucial. The grand vision. Despite the challenges, the vision of terraforming Mars is a testament to humanity's ingenuity and determination. It represents not just survival but also hope, the idea that we can create a second home among the stars. Terraforming Mars would teach us how to manage planetary systems, combat climate change, and build sustainable ecosystems. It would unite humanity in a shared goal, pushing the boundaries of science, technology, and exploration. And while the task is monumental, the rewards are equally profound. The choice ahead. Should we focus our efforts on transforming Mars into a new Eden, or concentrate on preserving and restoring Earth while studying Mars as it is? The answer lies in our collective vision for the future. Terraforming Mars is more than a technical challenge. It's a symbol of humanity's boundless curiosity and ambition. The red planet awaits, ready to be shaped by human hands and imagination. What do you think? Is terraforming Mars worth the effort, or should we prioritize other endeavors? Let us know in the comments, and don't forget to subscribe for more explorations of humanity's place in the cosmos. Until next time, stay curious and keep reaching for the stars.